This is question number 5, problem set 1114-14 of chapter 11. A stock has an expected return of 13%. Its beta is 1.10 and the risk-free rate is 4%. What must be the expected return on the market be? So given this information, this is obviously a question about CAPM, capital asset pricing model. So if we go to our course website, Saikai, go to the lessons. This is session 1, and you can find my PowerPoint lecture slides in the required readings. So open it. And pull down. You can find this is capital asset pricing model. So RI is the expected return on any security equals RF plus beta I. Beta is the measure of systematic risk for security times, this is called market risk premium, which is expected return on the market minus the risk-free rate. So this is the CAPM. The equation is very simple. And back to our setup, the question here is, we are provided with the expected return on this stock. So we know that RI, and we know the beta, and we know the risk-free rate, but we don't know about this RM. So we need to solve out this RM. But given the other inputs of this equation, this becomes a one unknown equation. So this should be pretty easy to solve out. So let me use my pad to do this. So again, I want to write down this is R equals RF plus beta times RM minus RF. So now this is provided to be 1.1, and this RF, back to the question set up, 4%. This is 4%. And this is provided to be 13%. 13%. So now we can just solve out. We need to know this. Basically, this question is asking about RM. But how can we solve out RM? So we can just first move this RF to the other side of the equation and change sides of the equation. So now equation will become beta times RM minus RF equals R. Now if we move this to the other side, we need to change the sign. So now this becomes negative minus RF. Notice, as I said, after I move the RF to the other side, then I change the signs of this equation. So this becomes the left-hand side, and R minus RF becomes the right-hand side. So to further solve out this Rm, I need to divide both sides by this beta. So Rm minus Rf equals R minus Rf. Now this divides by beta. So finally, I can move this minus Rf to the other side. Hence, I can solve out Rm. Rm equals the whole thing plus Rf. So now I can plug in everything. So R, as we said, equals 13%. So I use a decimal, 0.13 minus RF is 4%, and beta is 1.1 plus RF. So now I can put this into my calculator and get out the final solution. Or I can use Excel. So to use Excel, I can just type this equals 0.13 minus 0.04 divided by 1.1 plus 0.04. Yes, double check, just make sure. So back to the requirement, rounding requirement. That's a very important part of the work as well. So the rounding requirement, do not round to intermediate calculations, and that's why when I write down this expression, I didn't use the numbers. Only at the final step, when after I have expressed Rm in terms of all other inputs, did I input the numbers. Hence, I followed the rounding requirement. Do not round intermediate calculations. Enter your answer as a percent rounded to 2 decimal places. So now that means I need to change the format here. Right click on it and format cells and use the percentage here and decimal places too. So now the final answer is 12.18. So 12.18. Now check my work. Okay, great. So that's one way we can get the final answer. The other way is simply to use Excel. So use Excel, Rm. We need to know Rf, right, which is 0.04, and R, which is 0.13, and beta, that's 1.1. So that's what we know. And also, if we know Rm, then we can figure out this R based on the CAPM equation here, right? That's the relationship. If we know Rm, and we also provided with beta and Rf, hence we can solve out this Ri. But now we don't know Rm, but we know R. So what if we are provided with just any arbitrary number, 0.07, for example? Let's assume Rm is 0.07. Obviously, that may not be correct, but you'll see why I do that later. Now, the calculated, so this is R. So let me use R1, okay? So R1, based on this Rm, beta, and Rf, I can calculate this R1 to be, it's Rf, right? Based on CAPM, plus beta times Rm minus Rf. So basically this step, I'm trying to use CAPM to figure out the expected return on this security. As we said, obviously, because we just assumed Rm, so this R is also not the same as the actual R, which is 13% here. But that's not an issue because I want to use a special function in Excel to solve out this Rm, which makes this R1 to be exactly equal to this R. And how do we do that? We can use this function called data within the data tab and what if analysis. We use the goal-seek function. So here, if you pull out this goal-seek menu, you can see first one is the set cell to value by changing cell. So that means we need to change by set cell. This cell is the R1, which is B7 automatically. You see, that's B7 to value. Here, the value must be a numerical value. It cannot be an expression. So we have to set this to be this value. So it's a 0.13, right? So that's R. We know this is the security expected return. And by changing cell, so we change the RM, which is B6. So now you can see, once I click OK, you see what happened. Now you see, R1 becomes exactly equal to R, 0.13%, and that's exactly what we need. And only when Rm equals this 0.121818 will R1 be equal to R. So I have basically solved out this Rm. And then the next job is simply to change the expression to format the answer by following the rounding requirement. So this is the keep two decimal places after the percentage sign. So you see it's exactly the same as what we got by using the algebra.